Welcome back. This is actually going to be day 2 of lesson 6.4. More on factoring, more elaborate, really fun, very fun. Factoring cubes. Oh, can't wait to do this. You're going to do great. Here we go. Let's get started. Before we can factor cubes, I need to go over something you've seen on your last test, this cube root of 64, and I wonder, do you even know what it means? Because we're going to use the skill throughout the lesson today, so we definitely have to have this understood. So let's go over this. What does it mean to be a cube root? Well, first of all, let me explain to you something you already know. Let's recap something you know so you can relate to it. If I drew this square and I put a 64 in the middle, what would the root of that 64 be? That would mean what would the side of the square be, because we want to know what times itself gives me 64, since the area of a square is length times width, or 8 times 8 gives me 64, then it would mean that the square root of 64 is 8. Well, we're going to do the same thing today, only we're going to talk about this cube root. So the same idea, only we're going to be talking about a cube. So if I have this cube that you see over here, and I'm going to go ahead and find its side, I'm going to tell you that the volume, that would mean that the length times the width times the height is 64. What would each x be? What does the length of the side have to be in order for me to have a volume of 64? So a number times itself 3 times gives me 64, and that is 4. And so that's what it means to find the cube root of a number. So the cube root of 64 means 4 times 4 times 4. All right, so you've got that in check. And just a little side note here. See the index here? This is called an index. This index is 3. If you're wondering why we don't have a 2 down here in that square root of 64, it's because it's understood. So you don't write it, because if we don't see it there, we'll assume that it's a 2. Just like when you don't see a coefficient in front of an x, you assume it's a 1. That's the same idea. So now that we do have an index of 3, we have to learn how to do this particular problem. And so what would I do with this example that I've just shown you of cube root of 8? The cube root of 8 would be what times itself gives me 8. So you're trying to break this down, and you can do that this way if you'd like. You could say 2 times 4, and that breaks down to 2 times 2. And so once you have 3 of them, that gives you the cubic root, and that gives us 2. You can also go on your calculator and do this if you want to give it a try, and you're going to want to go to the key that has the following. On a graphing calculator, we're going to use the math functions. So go to math, and then you'll see here that your number 4, you have a cube root right here. Go ahead and press enter. And if I put in the 8 and I press enter, it gives you the answer of 2. So that's how we use a graphing calculator. If you're not using a graphing calculator, then the calculator sequence here would be that you go to a key that would be, it's actually your caret key, but you're going to use the second caret key, which really means that you'll be using the x root like this. You'll see that symbol right above that caret key. So you have to press in the 3 first, then hit the second, go ahead and hit this x root key and put in 8, and that will give you your 2. So this explanation here isn't the best, so follow this one, and that should help you along. 3 second, and again that's the caret key, which is the cube root. You're going to tell it, the x, that you want it to be a third index. That's what that 3 is for. And then the 8 is what you're trying to find in terms of your cube root. So if you want to use a calculator, that's a way to do that. And you'll probably want to, because we'll be giving you some pretty big numbers in these problems, so you want to have that ready to go. All right, one more thing to look at here, and that is, what if I had something like this x to the third with a cube root of 3? So what would we do with that one? Well, let's take a look. we simply know that a 3 index will counter a power of 3 because this really means x times x times x, which means the cube root of 3 things. I take out 1 for every 3 that I have, and so the final answer is x. So there we go. I hope you caught that. If not, we'll be mentioning it throughout the lesson today. I'll let you know what's going on. So let's move on to the lesson. Factoring cubes. Factoring cubes means that I have what's called sum of cubes, perhaps, and the sum of cubes should make sense to you when I point out this. Here's the word sum, and you'll notice that I have this x to the third plus b to the third. So there's your correlation. Sum needs a plus sign. So we have the plus sign. What else do I need to be in a sum of cubes? I need to know that the a to the third is a perfect cube, and obviously it is. It has a 3 on it. And b to the third is a perfect cube. So we're in a perfect cube, and now we have to learn how to break it down. And to break it down means this right here. This is what I have to break down my sum of cubes, and that's what we're going to do. And I have 5 steps to get the job done. These 5 steps will get you to memorize this boxed off a plus b, a squared minus ab plus b squared. And so let's get started on doing that. Here's our first example, x cubed plus 27. You're going to write this down as we go, and I have some steps for you, and here is step 1. The first thing we need to establish is whether or not we have 2 cubes. So in this example, x cubed, is the x cubed a perfect cube? And the answer is yes, it is, because again, the cube root of x cubed would equal x. How about that 27 though? Is that a perfect cube? Is there a number times itself that gives me 3 times that gives me 27? You can go ahead and use your calculator. I'm just going to break it down and tell you that 3 times 9 or 3 times 3, I ended up with 3 prime numbers. So the answer there is that, yep, I have a third root because there's 3 3's. All right, what's the next thing we need to do? So we've established that we're in a sum of cubes. Now what? Now in order to get the small quantity, and I'm going to highlight that for you in purple, the small quantity means I want to find this a plus b. That's the first quantity that I'm going to go ahead and write. How do I know what it is? I'm going to cube root the first term. I already did it. It's x. And I'm going to cube root the second term. I already did it. It's 3. So I'm going to write the x and the 3. And what am I in? I'm in a sum, so I'm going to leave the plus sign there. So this is my first quantity, and that is part of the factoring. Let's see what our third step brings to us. In the larger quantity, or I'm going to go ahead and highlight that in orange, that means I want to find this first term of the second larger quantity. And so what that means is I'm going to just simply square the first term that I had. Here's my first term in my cube. It's the x. So to find that that first number, I'm simply going to square it. Now I'm going to rewrite the quantity in front, the x plus 3. That stays in the problem. I have the x squared, and now I have to find 2 more. That's our last 2 steps. So fourth step, we're going to find the middle term. And the middle term wants us to simply go ahead and find the opposite sign and multiply the 2 cube roots. What were my 2 cubes roots again? My 2 cube roots are what I see right here, the x and the 3. And so if I multiply them, that would mean 3 times x. Opposite sign is negative, so negative 3x. So that would be how I find the middle term. Notice that it's negative. Very important. And finally, the last step is to go ahead and square the second cube root. So let's go ahead and square the second cube root. So that needs the word root at the end here. So square the second cube root means that I want to go ahead and take this 3 and square it. So I'm going to take this 3 and I'm going to square it. And so what would that give me? My final answer is going to be x plus 3 times the x squared minus 3x plus 9. Now if you're saying, whoosh, That would be correct. We usually find as teachers that this is a concept that takes a little bit of trial and error to understand it. So we're going to do some more problems and keep you following along with this. So hang in there. So I just changed things up a little bit here, and I do mean a little bit. I changed your sum word to difference, which means that the addition sign between the two cubes now became a subtraction sign. That is the difference between the two, and when it comes to our answer, the only thing that changes here is the fact that our plus sign became a negative sign. Again, we talked about that. But look at here, this sign also changes. Instead of it being a minus sign, it's now a plus sign, because when it comes to these two signs, you must always have opposites. So let's keep that in mind as we memorize these formulas. Just that little bit of difference from the sum of cubes. All right. In example 1, we have 8x cubed minus 125. And I'm going to go ahead and start this problem by telling you that 8x cubed could be representing the a cubed in our formula, and the 125 would be representing our b cubed. This might help you to follow along with the formula. So our job is to find the cube root of the 8x cubed. So I'm going to go ahead and put that underneath a cube radical. I'm going to go to my calculator, and I already did this problem for you in the PK. The 8 is actually a perfect cube of 2, and of course x cubed comes out as x. So the a value is 2x. What's our b value going to be? What is the cube root of 125? Why don't you try that on your calculator? And when you punch that in, what did you get? If you don't have a calculator, I'm going to go ahead and tell you the answer is 5, because 5 times 5 times 5 is 125. So a is 2x and b is 5. So we did our first step. We established that they were both perfect cubes. Our second step. For the first small quantity, which means the first set of parentheses, we're going to simply write our two answers, the 2x and the 5, and paying close attention to the fact that we are in a difference, I need the minus sign. Now the third step, I'm going to take my first term, and what I mean by my first term is this 2x that I've underlined in blue. I'm going to take it, and for my first term in the big quantity, I'm going to start it off by taking that term and squaring it. So the answer there would be 4x squared. And I'm going to keep that 2x minus 5 in front. That always stays the way it is. I wanted to show you how I took my first term, which is my a term. So there I go and take my a, and I went and I squared it. And so that's how you can follow along with the formula. I need now a plus sign, so I'm going to go ahead and write that before I forget. And my fourth step said, all right, I took the opposite sign and multiply the two cube roots. So I'm going to go ahead and I'm going to take my a, which is 2x, and I'm going to take my b, which is 5, and I'm going to say 2x times 5. And I'm going to make that my middle term. So, very simply, 10x. And finally, in the last step, I'm going to go ahead and take my last term, which is the b term, and I'm going to square it. So in this last one, I'm going to take that negative 5 and square it. And the reason why this last term is positive both in a sum and a difference of cubes is because a negative squared is always positive. You got it. So that comes out to be 25. And let me write your final answer for you. It's going to be what I started with, 2x minus 5. That's the difference. And I'm going to take my 4x squared plus my 10x plus 25. And that is how simple it can be. Getting a little bit easier for you? Now that we've been through a couple problems, it's time for you to give this a try. You do, however, need to have your 5 steps in front of you. Hopefully you've taken them down. If not, please do so. The expectation is that you need to have these 5 steps written down. So let's go ahead and see what this you try is all about. We want to factor m to the third minus 1,000. Follow your 5 steps. Press the pause key as you work and come back when you're finished. I'll have the answer for you. All right, so you've done your job and you've hopefully done it well. Let's see if you got the answer of m minus 10 times the quantity m squared plus 10m plus 100. How'd you do? It's not too bad, is it? It's just a matter of doing some of these problems and memorizing the steps. All right, so when I go ahead and do this next example, I just want to make sure you are so on top of that golden rule to factoring. Golden rule to factoring is always, 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 always look for the GCF. That is our golden rule. So now that we've got that understood, let's go ahead and do our example 3, because without that GCF, this problem right here could be causing you havoc and make you just frustrated, so frustrated. But no, you don't need to be, because we're going to look to see if we have a GCF, and we do. We know that 2 goes into both of these, so we know we have the 2, and the lowest variable I have is a c to the first, so they both are divisible by that c. What does that leave me with? It leaves me with this first one, the 2's cancel. The c, I have more c's up than down by 3. And over here, the 2 goes into 128/64 times. The c's cancel. And so I keep the negative sign in the problem. And on the outside, I have to put my GCF, which is 2c. So I'm going to go ahead and write that on the outside. Now I want to deal with this. And this is a difference of cubes. So we're going to follow those 5 steps, and we're going to cube root that c cubed and get c. We're going to cube root the 64 and get 4. Keep the minus sign in between. Remember, this is our a and this is our b as you follow along here. Keep the GCF in the problem. So what do we do for the first term of the second quantity? We square our c. So c squared is simple enough, c squared. I'm going to change the sign from a negative to a positive. I'm going to multiply c times 4, 4c, and I'm going to square that 4 to get 16, and the last term is always positive. So this is my final answer right here. My final answer is going to be this entire c squared, 2c times c minus 4 times the quantity c squared plus 4c plus 16. Now I'd like to take this time to prove something to you. If I go ahead and take this c minus 4 and multiply it by c squared plus 4c plus 16, I should end up with what? What I started with, which is c cubed minus 64. So I just want to prove to you why you need opposite signs. In order for me to start with 1, 2, 3, 4, 5 terms, I'm certainly going to have some cancellations here. So I'm going to need negatives and positives to make that happen. So here I go. I'm going to multiply the c times the c squared to get c to the third, and the c times the 4c to get a positive 4c squared, and the c has to multiply that last term, the 16, or 16c. Then I'm going to go ahead and take that negative 4 and multiply it by c to get a negative 4c squared. I'm going to take that negative 4 and multiply 4c to get a negative 16c. And a negative 4 times positive 16 is a negative 64. And watch what happens here. I'm indeed going to get these to cancel. And what am I left with? I'm left with the c cubed. I'm left with the negative 64. And that is the exact reason why you need negatives mixed with positives. So now that you understand the logic to that, hopefully it will help you to understand how the sum and difference of cubes play out. Now the hardest thing that comes up with factoring is when we as teachers put everything together on a test or a quiz. So when Miss Dasher and I give you your next quiz, the hardest thing for you will be, I don't know, am I going to use MAF? Am I going to use difference of squares? Am I going to use the cube formula? And so I'm going to put some problems on the board and have you just challenge to see where they go. Now I would not write this. We just want to see if we can figure things out as we go. So if I give you something with four terms, and there's no GCF, then I know I definitely have no choice but to put this in a factor by grouping. So when you see a 4, you're going to think factor by grouping. The next one that I have, let's see what I have here. I have 6x cubed plus 21x squared plus 15x. Now there is a GCF there, so that might change where I want to put this whole idea, how I want to do this. So if I take out the GCF, which is 3x, I'm left with 2x squared plus 7x plus 5. So this is where I want my focus to be. Now that's just a regular old trinomial. That's all that is, with the GCF on the outside. So that's why I always look for the GCF first, because that ends up being a trinomial in which we will use the MAF process. All right, let's see what we have coming up next. We have 4x to the fourth plus 39x squared minus 10. What do we do with that? Well, it looks like it's a trinomial, and since there's nothing that goes into the 39, 4, and the 10, I don't have a GCF, so I'm going to deal with this trinomial and put it right underneath the trinomial, because that's exactly what it is. So I would use the trinomial MAF to solve that one. Oh, here's an interesting one. What's my GCF? Let's look at that first and see how this breaks down. I'm going to divide out a 3x, and that means that I would have x to the third minus 8. Ooh, with a 3x on the outside. Ooh, bing, bing, bing. We know what this is. This is definitely a difference of cubes. So we're going to go ahead and put that in the cube category. So this one belongs with the cubes. See how we do that? Look for the GCF, figure out what we got left, and see where it's going to go. GCF here? Yes, we do. We have an x is all we have. Every one of these gets an x divided out, since they all have an x in common. That would leave me with 3x to the third plus 9x squared plus x plus 3. Well, this right here is our focus, and since there's 4 of them, it's going to be in the grouping with a GCF on the outside. So this one will be for grouping. All right. And do I have any more? I have one more to go. And you can tell that I'm going to take that 8 out of here. And now take the 8 out, and what will I get? I will get x cubed minus 8. So that's a sum of cubes again. So that one's going to go in the cube category. And let's try one more. This 3x to the fourth minus 300x squared. Looking at that GCF again, I'm going to take out a 3 and an x squared, right? And that would leave me with a 3x squared on the outside, leaving me with x to the second. And over here, 3 goes into 300 100 times. And the x squared canceled out. It was pulled out as the GCF. My focus is what's on inside the parentheses, and that is what? That's a difference of squares. So it looks like our final example will go into the difference of squares. So I hope that helped you to analyze your problem when your polynomial when you get it, and figure out where it's going to be processed through, either a MAF trinomial, MAF grouping, difference of squares, or sum and difference of cubes. I hope that helped you. So in our wrap-up, it's very clear that we need to memorize this formula for sum and difference of cubes. There is no other way to get around it. And an important key fact here is that the plus sign starts in the first quantity, means that the middle term of the second quantity will be the opposite, so that you get terms to cancel out. And the reverse is true for the difference of cubes. And finally, we learned how to analyze the terms and decide what process to use before you even start to factor. And that takes care of 6.4 day 2.